Hi there, my name's Darryn Campbell. I'm formerly an Android developer, and then I moved into Android developer relations, and now I work for a company that delivers real-time solutions, also in developer relations. So I thought it made sense to deliver a talk on adding real-time features to your mobile application. So my background is in Android, but everything I'm going to say is very high level. It applies equally to iOS as well. I put an agenda together that was honestly a bit of a joke when I put this slide. So don't worry, not all of the slides in this presentation are quite this full of text. In fact, this is the biggest one. But I'd like everyone to leave this talk with an understanding of what real-time features mean on mobile and how you might go about implementing them, and especially some of the unique challenges that you might come across as you go about implementing your own real-time features into your own applications to enhance your capabilities. So without further ado, what is a real-time feature? Now, this is a conference, a webinar aimed at real time. So I would imagine that everyone listening to this recording or this webinar live has an idea in their own mind what a real-time feature is. But I would suggest to you that your notion of real-time features, capabilities are not the same as anyone else on this call. And like to bring that point home, when I was putting this deck together, I pretended I was a application developer. I was submitting an application to the Play Store, and you get this kind of disambiguation dialogue, and you have to choose what kind of application you've developed in order to submit. And I hadn't realized just how many kinds of application there are until you sort of go through. And that's what the animation is there. You see, even games, there's a scrollable list of things that you can select, or just an application. It might be a game, it might be dating app, education, entertainment. There we go. It's prompting me now. Lifestyle. So all these different types of app will have different kind of real-time features. And the obvious real-time feature, I think everyone kind of gravitates towards, is messaging. That's like the first example I gave on the left there. Like you send a message, you can react to that message, you get read indicators, you know if the other person is online or offline. All of those are examples of real-time features that you would find in a chat application. But not every application is chat, which is real time. So you might have a Twitch clone or something that you've developed where you want to notify other people that your stream is starting soon. Or what's another example here? Like Frank has walked 1,000 steps. So maybe you've developed a fitness application, and you can kind of walk through in your mind what real-time features you would have in that fitness app. So Frank has achieved something, so the app would be notifying him in real time his progress towards his goal, whether he's achieved something, how close he is. But then there's also the social aspect. Maybe it's prompting him to share his experience with his friends. And then you have the notion of a friends list, whether his friends are online or offline that he's added to his fitness application. And then when he tells them how close he is to his goal or he's achieved his goal, then they can react, or they can send encouragement, or I think I've jokingly said they can send a cake emoji. But all of this is real-time interaction, and it's different because it's a fitness app, and you can extend that to all other sorts of categories of app. And that's what I've tried to do on the next slide. And don't worry, I'm not going to read through all of these different categories, but I just like to highlight a couple of them. Communication down in the bottom left there, I've sort of mentioned that. Chatting, user presence, online or offline, friends lists, delivered, read, check marks. All of those are kind of familiar, I think, to everyone on this call. But like maybe you're not doing a chat app. Maybe you're adding chat into an existing application or a different category of application. This is something that's quite popular to do, like the weather app, let's say, the weather category. I'm creating a weather application and I'm notifying people in real time there's a storm coming. This is a very important piece of information which I need to deliver. In fact, the user might be offline or might not be running my app when I want to deliver that information to them. So it might have to be as a push message. More about that in a couple of slides. But maybe I'm getting information from my IoT stations, and they're delivering real-time weather updates to my server, and then my server needs to deliver real-time updates to my app and to say the weather is clearing or take shelter in a storm bank. I don't know, maybe I'm getting a little bit much. I can't remember the last time I got that kind of update from my weather app here in the UK, but you can imagine the kind of scenarios that your application would have to deal with. The other thing I wanted to mention on this slide was the gaming component. So we've been dealing with an awful lot of gaming customers lately in my day job. And the feedback I get from those customers is like there's two types of games. Like every developer wants to create a game that's going to be popular and bring their users back time and time again. And there's two ways to do that. You could you could be nefarious and try and use psychological techniques, for want of a better word, to lure people to come back and make your game addictive. And like, that's one way of doing it. I think most of the developers I speak to don't like creating that kind of game, and I think most people don't really like playing that kind of game. But the other side of that is we still want people to come back to our games. We want to make them enjoyable and engaging. And the way that game developers and probably other type of developers achieve that is by creating a community around the game or the application, so people feel part of something, and that's what makes them come back. They want to come back, they want to contribute, they want to see new things happening. And I would posit that the way to create a community is to add real-time features to your application. So in the case of gaming, the very real use cases you had, like you have a live leaderboard, for example, which updates in real time. Maybe it's an achievement which someone is trying to aim towards. And you can imagine they're playing the game, and as they're playing it, trying to reach this achievement, the achievement updates in real time, which might be frustrating as you're playing it, but it's probably less frustrating than getting to the end thinking you've made that achievement and then only to find out later that, oh no, it updates asynchronously and I hadn't achieved, I celebrated for nothing, blah blah blah. So all the better to have that leaderboard in real time. And the examples continue. You could have friend list, again, online, offline presence, and you want to invite people to a lobby, maintaining the state of that lobby. People could drop out, you could kick them, metaphorically, of course, out of the lobby and start the game. And then when the game's playing, I don't know, it depends on the type of game. Maybe you're shooting people, maybe you're racing them, you have the cart position, for example, all of that. So, yeah, I'm not going to go through all of these categories. We will be here in excess of the time allowed. But to continue, that's all the different categories that you might have. Let's think about now, having been convinced that we want to add real-time features to the app, how would we go about doing that? So I just want to walk through slowly and let you hopefully leave this slide with the impression that it's not easy to do. Well, it's not easy to do. So, but what would be easy is if we just had two people playing our game or using our application. So here, maybe we're just sending messages from one to the other. We have a unique IP address, let's say, of the device. That would work, but it's not very convenient targeting a device through IP address. So we would add in, and I do apologize, but I'm from the school that likes animations in their slide deck, so I apologize in advance. So yeah, we have some kind of registration workflow. So we register the device, maybe the user registers on the device, so we're sending a message to a user rather than a particular device. And that would work. You can imagine there's other arrows that are all registering from these 5 devices. Now we've got 5 people playing our game. Obviously, I went a bit mad with the copy and paste. It is just Android and iOS. I've used a generic image, but you can imagine this applies equally to both platforms. But this is only going to scale so far. We've still got every device addressing every other device. So let's add some kind of cloud platform to mediate all of this communication. And you can kind of imagine these are the steps you go through as you start building up your real-time architecture. We've added a little bit of a latency into the solution now, but at the expense, well, I suppose the expense is the latency, but the benefit is it makes everything a lot more scalable, a lot more achievable. We can mediate conversations, everything's going through the cloud. We've got a lot more control. And one thing we can also add in as we do this is storage. So you can imagine some of those scenarios I talked about earlier. Let's think about the game scenario and the kart scenario, let's say, like Mario Kart. I think a lot of people will be familiar with Mario Kart on this call, has the ability to replay ghost data. You're not recording the individual video frames of the character as they're moving around. You're recording the kart motion as it goes around the course, and you're storing all of those in a database for later replay. Obviously, that scenario could extend to any other category, but you imagine we store this real-time data as it's happening. I will talk about a little bit more about that on the next slide, actually. But yeah, our game is very popular. Number of users increase, and we've gone global. And if your favorite flag is not shown, then there is a conspicuous amount of white space still on the deck, so it's not too late yet. So yeah, we've got flags throughout the world, all going to the same cloud. Probably not going to scale that well, so we had another data center here, and obviously we want the people in the US to communicate with the people in the EU, so we have a communication between clouds. Again, we've added latency, so we need to be cognizant of like the overall route that our traffic is taking through the network. And something else worth pointing out here, as we add like a cloud for each country, it's not just going to be a single cloud. Like obviously, in the real world, like there's multiple points of presence in the US or in the EU, for example, for each of these clouds, like it's GCP or AWS. So just bear in mind that like your software or whatever software you're using needs to be intelligent enough to route its traffic to the nearest point of presence or the point of presence that has the least amount of traffic. So it's going to have the best performance going from one point to the other. A point. Okay, so yeah, we've got our popular game. More and more people are playing it. This is really great. And now we've got different countries. We've expanded into some of the most populous countries you can imagine, and we add in more devices, we add in more clouds. There's more storage. Incidentally, you need to have some kind of algorithm how you're doing your storage. Like you probably have a secondary database, and you need to like handle failover if one of your databases goes down for any reason. And then you have questions of what's the uptime of my application. Really narrows into the cloud services that you've selected. A lot of this stuff you will get for free by the cloud provider if you're not doing this yourself, but it does, of course, require you to know what you're doing and maintain and understand your costs, especially for some of these clouds. But I said you get a lot of this free with the cloud providers. What if you're in a scenario where you're not able to use your favorite cloud provider? Now, I've put China here as an example that I think everyone can understand. If you're using a GCP for your cloud, doesn't run in China, oh no, what do? You have to run everything potentially on your own private server. But that's not the only scenario where you'd have to run on premises. Like we've had customers in the past where but you have stipulations, like you have a very very popular application, and all of a sudden like it's being piloted by a major like retailer or a major warehouse distribution center, and like you I mean, you can imagine a hypothetical scenario where Amazon want to use your app or they want to use aspects of your app, but obviously they don't want that data going through Google's GCP. So, yeah, you might have to run on premise for whatever reason, go through their VPNs, and that's going to again have communication to the rest of your solution, database, etc., etc. Basically, things can get complicated very quickly if you try and build and maintain your own real-time architecture. But I hear you say, like Darryn, this is misleading. This data you're giving us, because this chart, this diagram, would be equally applicable to like any real time solution. Like it wouldn't just have to be mobile. It might be desktop, machines. And we've seen this in the past two presentations. This exact same diagram. So I apologize for that. So let me talk about some of the unique challenges that you will have on mobile. And I mentioned my previous experience with Android developer relations, and from Marshmallow up until Android 10, every year I would have to give a presentation to like the changes between one version of Android and the other. And I would always have a slide on some of the new restrictions that have happened for applications that run in the background. In fact, one year it was actually just called background restrictions. And so, but the point is, your application is very restricted what it can do when it's not running in front of the user. And when I mean restricted, I'm talking in terms of CPU cycles, I'm talking about network access, and the only way to wake that application up in the background is by sending it a push message. So whichever real-time infrastructure you choose to develop, and if you are developing your own, like I was on the previous slide, also make sure you have the hooks in there for push messages, so that if the user is in the background, you have some way of bringing their application to the foreground, having them launch it before you start sending them all their real-time events that they need to be made aware of. Also, cross-platform support. So everyone everyone is familiar with iOS, Android. At this point, I think most people are familiar with some of the difficulties of creating an application which needs to run on both of those platforms and run on the web and be done in a cost-effective manner. And different teams approach this issue differently. Like some organizations will have a separate application for iOS, a separate native team to develop the Android client, and a separate web client. And all of those will work because they're talking to the same backend databases. And that works, but just make sure that if you're not writing your own real-time infrastructure, whichever SDK you're using, or whichever solution you're using, has SDKs that support all of those native platforms. And it might not be a native platform. Maybe you've decided to write everything in React on the web. Maybe you're using React Native to run cross-platform and sort of compiling it that way. Regardless, that's just more platforms that your real-time solution needs to support. And then database synchronization. I talked about databases on the previous slide, but a lot of time when people think about mobile and synchronizing the backend database data, you're thinking in terms of like the example I normally use is prices. So the price of items are in a database, and let's say you're scanning items with your mobile device handheld. Every week, these prices update. You need to reflect that database's values on the device so that it's not doing a lookup every time it needs to scan an item. So that's a scenario I think a lot of people probably familiar with like personal shopping. You can imagine that kind of scenario. But real-time data does not update every week. Real-time data updates multiple times a second, potentially. So just bear in mind that if this is something that you need to store in the database and you need to always have access to the latest data, I don't know, it's an architectural decision at that point. And what you probably end up with is your database storage being eventually consistent. I don't know why I'm doing air quotes, that's the actual term for it. But yeah, it's another thing to consider with real-time data. The other thing is related to that, but time-sensitive information. Not all real-time data will be as relevant forever. And the common example I use here is I'm getting a food order, like I've ordered from Uber Eats or Deliveroo here in the UK, and their driver is on the way with my food. I'm very hungry. Well, I'm not right now because I've just had a meal. But you can imagine that if I'm told where my driver was 2 minutes ago, and I'm also told where he was 5 minutes ago, I don't care where he was 5 minutes ago. I only care about where he was 2 minutes ago. And like obviously that extends. I only care where he was a second ago. The more frequent you can tell me these updates, and in fact, when it comes to these kind of updates, maybe it's okay to use UDP rather than TCP. Another complication when you're developing your infrastructure there. But yeah, we don't care about old information. Maybe you don't even need to record it. Maybe it's stored separately for analytics purposes. Yada yada yada. And then finally, network bandwidth. I think this is something which developers are familiar with nowadays, thinking about, like, I'm comfortable in my office in San Fran or in the UK, in my case, but I know people are using my device in rural Virginia, let's say, as an example, and they don't have the bandwidth I have. That's all very well and good. People are cognizant of that. But real-time applications on mobile tend to be used, or some use cases tend to be used in areas where bandwidth is restricted for other reasons. Like think of a concert event, like I'm reacting to a concert that's happening around me in real time, or a sports event. I'm in the stands, I'm interacting with other players, I'm cheering on, I'm getting updates of where my players are on the field because they're probably too far away and the seats I can afford, so I can't see them. And like that data, I don't have much bandwidth because there's 50, 40,000 other people around me. So okay, bear that in mind as you're developing your application. And then other things to consider, SLA, so what your uptime guarantees are for your application, how you scale geographically, number of devices, support, and importantly, do your costs align with your revenue model? Because honestly, anyone and their grandmother could create this kind of solution if cost is no money. Cost is no money? Cost is no factor, sorry. But we live in the real world, or at least some of us do. And so like you want to grow organically at the same time as your cloud costs do. Okay, so a couple more points before I end off. Just talking about implementation. I hear this from a lot of people. I'm just going to use Firebase Cloud Messaging for my real-time features. Whenever something happens in real time, I will send a FCM, which does support iOS as well, very popular on iOS, but it's not just a FCM, maybe it's a PNS on iOS. The principle is the same. Please don't leave this presentation thinking you can deliver all of your real-time features by sending push messages to devices. That's not going to work because the OS will throttle the amount of messages you can send. In fact, I had a gentleman on LinkedIn asking me how he could bypass this just yesterday, and unfortunately, I was unable to help him because you just can't do it unless you root the device or whatever else, or have user interaction. But anyway, that's a different topic. Yeah, so don't rely on push messages to deliver your real-time features. And then equally, I should apologize. I've got like a spinning elephant. That's because this was supposed to be the elephant in the room. I should have explained that on the previous slide. But anyway, the other elephant in the room is, well, okay, can't I just use Firebase? I know Firebase is very popular amongst developers. That's why I'm picking on it. But I thought, can you for like a chat, for that chat solution that we're all familiar with? So I typed into Google, how would I implement a chat with Firebase? And it gives a really good tutorial. At least the screenshots look good. And it uses a real-time database, and one device sends a message, it writes to the database, and then the other device is listening for changes in that database. And when it sees the change, it displays the message to the user. And that does scale because the real-time database is a Firebase real-time database. It scales to any number of devices. That's great. But I would argue that that's where the tutorial finished, and just where any kind of chat application gets interesting. How do I do things like pinned messages or typing indicators or message threads, private conversations, emoji reactions? Like all of that at that point is fitting a square peg in a round hole, trying to write to the database each time and then having a very complicated schema. I apologize if you can hear my dog in the background, by the way. Okay, so what else could we do? We could write the whole thing ourselves, like I explained a couple of slides ago that I keep harping on about. It took me a long time to put that slide together, so that's why I keep harping on about it. But it's not just everything I've mentioned. There's other considerations, like maybe you've got compliance, so you need to go through compliance activities with your solution, or even very popular. I'll come back to chat because we all understand that, but the ability to intercept messages, to moderate them, to change them, to hold them so that they don't get through to their destination, to do translation on the fly in live. All of that adds complication to what would otherwise be a simple architecture. So just bear that in mind. What you might want to do, and I'll skip this slide in the interest of time, is to go with a nice middle ground. So the more flexible approach is to use an infrastructure as a service. I keep doing the air quotes. Maybe I should have had definitions at the back of this slide deck. So here, there are multiple companies who offer real-time solutions over a publish and subscribe mechanism. So MQTT, for example, has RabbitMQ, and you don't have to worry about the architecture in that instance. And it would be great if you were to choose a solution that could also incorporate push messaging support, to handle background apps, to notify the user that there are real-time events to action on. And so this isn't a sponsored talk, so I'm not going to belabor the point, but I work for a company called PubNub. I would recommend that as an infrastructure as a service solution that delivers real-time features over publish and subscribe. Don't take my word for it. Not a word to a lie. Putting these slides together, I searched for Android real-time communication, and the top answer on Stack Overflow, eventually from a few years ago, but it was from, I won't try and butcher, of course, Shubhant Gupta's name, was saying PubNub, and amongst a lot of other examples that he gave. So yeah, I wouldn't work for us if I didn't recommend us. And we do everything which I spoke about in the in the previous slides. So push, automatic FCM, APNS integration, access control, functions, messaging, compliance, 5.9 SLA, all of that. So with that, I hope you have enjoyed the presentation. I've been Darryn Campbell. If you need to contact me, please, it sounds horrible to say, but please Google me on I'm on LinkedIn. I'm on Twitter. My parents spelled my name in a very strange way, which has benefited me in later life because it's easy to find me if you just type in Darryn Campbell real time or Darryn Campbell PubNub. Yeah, please get in touch. Any questions? I'm happy to help. But other than that, thank you very much for listening.